So we type the equation in. Now, here's what we have. Most of you are on your standard window, just your 10 by 10 grid. And a 10 by 10 grid is not going to do us a lot of benefit if I can't see the whole quadratic. Okay? So I can only see like half of the parabola, which is the path that the frog took. Now, first question I have for you. When we look here at this picture of the frog, do I care about the negative x's or the negative y's? No. So when I adjust my window, I don't need to have those negative values. The other thing we need to do is kind of estimate or guess how far out do we want our x's to be so I can see the end of my parabola. If we're wrong, we'll just adjust it later. But how far out do you want to try? 30? Okay, we can go from 0 to 30. So let's write that on our paper. We'll do 0 for x's to 30. And what do you want to make the scale? It doesn't truly matter, so just pick a number. 5? Make it go by 5s. It could be whatever. Now the y's, can I see, do you think I'll be able to see the top if I keep it 0 to 10? Alright, so we'll leave our y scale 0 to 10. And we'll go by 1. Do you guys remember how to adjust your window? Yes. Yep, where do you go? Press window. You press window. We're going to type all this in. So we'll go 0 to 30. We went by 5s. And then 0 to 10. So this time when you hit graph, you should be able to see the whole path of the frog, which we can. So that's the thing. If for some reason we couldn't see the end of it, then we would just go back to the window and make the x's a little bit bigger. We good there so far? All right.
I have a question.
Yes.
Would we have to do that ourselves? Because I don't know how you pick those.
Well, we're gonna keep doing that. But yeah, you'll have to figure it out. But the more you do it, the easier it gets. But mostly we just kind of guessed. Like we said when it was at 10 here, like, oh, we can only see part of it, so we just guessed a bigger number. All right, so the first question asked us, how far did the frog jump? So that means you're trying to find where the frog lands on the ground, which is the X-Intercept. All right, we're trying to find the X-Intercept, which on our calculator, what do we have to trace? If I hit second trace, which option do I choose to find the X-Intercept? 0. So we choose number 2. And it's going to be the same process that we did a couple units ago with our calculator. To find the 0, we have to take the cursor a little bit to the left, which over here is going to be a little bit above this X-Intercept, and hit enter. And then you go a little bit to the right. Now let's say you oh no. Do you want to use mine inspired? And you should get pretty much what I got, 20.34. What? Got an error? So be careful here. When you do your left bound, you want it to be a little above. When you do your right bound, you want it to be underneath the X.
I got an error.
An error? Let's see. Sign change. Okay, so that means that you didn't go all the way above and below. So here, like if you're, so we do enter. Now make sure you can't see it there at all. So you gotta go way underneath.
Oh, I got it.
Flashing anymore. Enter, enter.
Wait, tell me what the X is.
Must be so cool.
Was it 0.31?
Yeah, second. Hold on, let me, while I'm fixing this, let me, which one of these numbers is how far the frog jumps? 20.34. So we'll go to 2 decimal places or so. How I traced the X-Intercept. I just went through that.
Yeah, I keep getting weird numbers.
Okay, I'll come in a second. So this frog went 20.34 feet. So that means the frog started to jump, and that's an actual, like, not made up number. Like, frogs can actually jump 20 feet. So I would say that's like here. So see that tree out there? The little one? Probably about here to this. Come on. It's that's at least 20. That's not a football. Now, if I were doing this by hand, yesterday we did all this work algebraically. If I were going to find where the frog hit the ground yesterday, what feature factor of what would you have to do to find the x-intercept? Factor. So yesterday you would have to factor in order to find this value. And I wouldn't really want to factor this quadratic with all the decimals, so it's nice that we have our calculator. The next thing, we want to know how high the frog jumped. What is the maximum height of this frog? So let's again use our calculator here. When I go to second trace, if I was going to decide how high the frog jumped, which value would I choose? Which number here? Maximum, number 4. Now, maximum on the TI-84s are very similar to finding the root. You have to take your cursor to the left of the maximum. If you have an Inspire, it's a little bit faster. It's super slow on the smartboard. Come on now.
You can't hold it.
No, it doesn't let me hold it. The old software let me. It doesn't anymore. So I'm going to hold it to the left of the max. So hit enter. Arrow it to the right. Enter again, and guess. And you should get about 10.17 and 3. So which one of those numbers is the height? The 3. So this is how far away, like when it was 10 feet out in its jump, it got 3 feet high. So if you can picture this a little bit here. So the frog, 3 feet, I don't know, this high, a little over half of me, right here. So the frog only got about this high off the ground, but it jumped 20 feet. So it's a very, not high, but a very long jump. So it's about 3 feet high. Now, if we were doing this by hand, not on our calculator, you would have to use the formula x equals the opposite of b over 2a. We did that yesterday, and there's going to be a homework problem that uses this formula today. All right, so finding the maximum uses this formula from last unit. Then you would have to take that x value, because we found this was a y coordinate. So you'd have to take whatever this x is and plug it back in to the equation. Okay? We're not going to do that by hand right now. You need to understand how you use that one. Okay? And lastly, one new thing on your calculator. How high is the frog? 2.25 seconds, or feet. That should be feet. That was a typo. 2.25 feet into the jump. So when it's just like a little bit away. How high is the frog? Now your calculator will find this value. You don't even have to use the equation. So here's what you'll do. You'll go second trace, and then Alyssa, I'll show you this on the Inspire. Second trace, you're going to actually choose number 1, which is value. And in the x, the flashing x there, you're going to type in 2.25. And when you hit enter, it'll take you right to that spot on the graph and tell you that the frog was 1.18 feet off the ground. So like 2 feet in, it was a little over a foot off the ground. 1.18. Okay. Now let me show Alyssa real quick. On hers, because so the hardest part about these problems is figuring out what to make the scale. This one, when I have a picture, makes the window pretty easy to find. So this is a picture of a shot put thrower. And we have the equation of this shot put throw. So the first thing I want you to do is we're going to type this equation into the y equals, and then we'll talk about how we're going to adjust the window so that we can see it on our graph. So take a second there, type it carefully, make sure you have the negative 0.0241, so don't lose one of the zeros. Alright, now we need to adjust the window. And in order to adjust the window, when there's a picture given to you, like we have here, this helps us decide what to make the window settings. Now, you can imagine in real life when you throw the shot, but it actually comes down somewhere over here and is going to hit the ground. We just don't have that on the picture. So when I'm estimating, my grid only goes to 30, but obviously the shot put lands farther away than that. Well, how far out do you want to estimate to make your x maximum? 50? We can do 50. You could do 100. So let's do 0 to 50. If 50 is not big enough, then we'll just change it. Well, let's go by 5s again. And it looks like here I can see the top of my grid using this window. So I would go 0 to what do you think? 20? Let's do 20. You could do 15, but let's go to 20 just to be sure. We can go by 5s there. Now again, if it doesn't fit the grid, then we'll just change it. So we have it typed in.
Look at that.
Window, 0 to 50. Go by 5. 0 to 20. And go by 5. So it looks like it fits everything on there. Okay, so when they give you a picture that has a scale, that is going to help you set your window. Then we'll do a couple here that we're not going to have. Okay. Yes. Let's see. Which part? Okay. So the first question it's asking us is, how long is the throw? Yes, Jamie. Question?
No.
Okay. That's okay. All right. How long is the throw? What feature of the graph are we looking for here to see how long the thrower throws? Which feature? The X-Intercept, the 0. So let's trace the 0. Second trace. Now, you guys know it takes me forever on my board here to do it. So I'll have you find your 0. Yes. I feel like 46.41 or so? Yeah? Okay. So when it asks you how long is the throw, or when does it hit the ground or something like that, you're trying to find the X-Intercept. Now here the next two questions go together. It says, when does the shot put reach its maximum height? So we're asking, when do we get to a maximum? That would be, like the X coordinate there is, you know, typically you think of time, but here we're thinking how far away from the thrower does the shot put get to its maximum height? And then what is the maximum height? So here, just like the last problem, when I'm trying to find the maximum, we'll do second trace, number 4, and you'll bring your cursor a little to the left, and we'll figure out which point is which here. And a little bit to the right. And we get 20.75 and 15.87. You should all get there with your calculator when you trace the max. Which one answers the question of when do you get to the maximum height? 20.75. So that's about 20.75 feet away from the thrower is when it gets to the highest point. So that's this one here, 20.75 feet. And then what is the highest height that this shot put gets to? 15.87. That's okay. That's fine. Yes. Next one here. Now lastly, it says, what is the height of the shot put when it is 15.5 feet away from the thrower? This is that new feature we did, the second trace, where you're going to find out what's the value at 15.5. So your second trace, you choose value, which is number 1, and you're just going to type in 15.5 and then hit enter. Did it give you a better number this time? Still give you 3? Okay. Maybe the next problem will be better. Alright, so we're about how high? 15.21 feet high? Check that you typed your the equation incorrect. Because this should give you the right value exactly. So 15.21.
Oh, yeah. Okay.
Oh my goodness gracious.
Alright, I feel like this problem, let's move on from it. Let's move to the next page. We have a multiple choice. So this one is more challenging because there is not a grid for you this time to base your window off of. So we're going to figure out how do we decide on the window setting when we're not given a picture to look at. So we're going to start by typing this equation into the y. That's the first thing I would do. Let's type in 0.3, and we'll talk about the scenario after we type it in. But instead of n, you need to use x's. You can't use any letter other than x in your calculator for graphing. So 0.3 minus 90x plus 12,450. Now before we even graph it, let's talk about what the scenario is. This is about the cost of making cars. Okay, producing cars. And we need to figure out which of the following is the lowest cost per car. And we'll talk about all of the rest of the variables in the question here in a second. But first, we need to figure out our window setting so that we can find the lowest cost per car. So I want to talk about, we're going to kind of make a picture here. Let's talk about what this parabola is going to look like when we graph it. Because if I hit graph right now on the window setting we have, Can't see it. It's not there. So we need to figure out what's the correct window setting. So let's talk about this graph. If I look at point 3, is that number positive or negative? Positive. So we know that our parabola is going to open up, right? So we know it's going to be somewhere up here and it's going to open up like this. The next thing we need to think about with our graph is where is the Y-intercept? 12,450. So right now our window I think only goes to 30. So it's definitely not high enough to see this. So we need to somehow make our window at least so that it goes from 0 high enough to see our Y-intercept. Now, do I really need anything above the Y-intercept if I'm looking for the minimum here? No, so I'm going to make my Y's from 0 to 12,450. And the X's, we're kind of stuck. We don't really know. Let's pick something. And then if it's not big enough, we'll adjust. So how far out do you want to make the X's go? Just pick a number and we'll...
200.
200. Okay, and if 200 isn't big enough, we will adjust. So let's go out. Window. We went 0 to 200. And I'm going to go by 50s. Well, we did 200 on the board, but if 300 works, that's fine. And then we'll see. We're showing them how to troubleshoot here.
Yeah, Lauren, you're ruining it.
0 to 12,450. And I would also go, I don't know, by 100 maybe. 200, it doesn't matter.
Is right.
So we decided on 200, and yet we couldn't see the whole thing. But Andrew said, and Lauren said, 300 seems to work for X max. So that's what you do. If it doesn't work, you just pick a bigger number, big graph, and say, oh, now it looks a lot better. Okay? So we have our picture. Now we have to figure out what the question's actually asking us. It asks us if we're producing cars, building cars, we want to know the cost is C, the number of cars built is N. What is the lowest cost per car? So when you're building something for a business, you want to spend the least amount of money. So it's the cost to the company. So here's the thing. Let's think about if cost is the X or the Y variable in this scenario. Look at your letters. Yeah, cost is going to be the Y. The N is the input, number of cars. So the cost is the Y variable. So we need to trace the minimum here and then use the Y value from the minimum. Right? So we're going to this time trace number 3, our minimum. We'll enter over. We'll do the other one here.
It's not.
And which value here is the minimum cost to make a car? 5,750, and that happens when this company produces 150 cars. Okay, so 5,700. Jamie is very giggly today. Which is A.
My graph is literally gone. It's not.
Did you change your window?
Yeah. It's not there.
I'll look in a second. All right. Let's move on. We have one more, guys. This is bad. It's been a rough day in general for me. I don't know. Maybe it's me. I don't know. No, it's this day. It's this day. It's just. I'm going to focus on the window set. So we have an object, what was called a rocket or something. This rocket's fired, and we have this parabola, negative 16t squared plus 112. First of all, before we even start with the graph, how could we find the height that the object was fired from? How do you think, using that equation? Give you a hint. If you're fired, like if you start somewhere, what's the time?
0.
0. So if I want to find the height at time 0, I'm going to put 0 into the equation. You're finding the Y-intercept, basically. So if I put negative 16 times 0 squared plus 112 times 0, what do you get as the starting height? 0p. So this object, whatever it is, starts on the ground. And it's shot up into the air. So we need to adjust our window here so that once we type this in, we can see it. So negative 16x squared plus 112x. Now let's make a guess. We don't really know how high it's going to get, but what do you want to make your x window, and then we can adjust higher or lower. Let's just pick something. 0 to 30. Okay. You can go by 5s. It doesn't, or 2s. I have 2, so we're going by 2. Y minimum is 0. And how high do you want to make the Y max? 57. Let's just, we can do 57. Why not? 5. Now if I hit graph, and we go to 57, can I see the whole thing?
No.
No. So we need to make the Y's higher. What do you want to now try the Y's to be? I think higher than that. Let's try 100.
157.
Okay, 157. Still not high enough.
Okay, 257.
Okay. Why do you have an error?
I've got a good feeling about this one.
So let's go 257.
Third time's a charm, buddy.
Just try second one. All right, so we have our window here. So when we make this picture, we can sketch it on here. It looks something like this. Right? I'm going to ask you just to find a couple of things. The first thing is to find the time and the height that the rocket is at its maximum. So I want you to take a second here, and I want you to trace the maximum value. And we're going to check it when we're done. Like, I want you to do it right now, and we'll check it, because it's going to take me a long time to click through on my calculator. I want you to find the maximum, and we're going to interpret what the ordered pairs mean. But it's just a little faster for you guys. And then if you need help. The hardest part is just using the calculator here. Like the rest of it's not hard to know what you're doing. What? Window? I think we want 0 to 30 for X, and then about 0 to 200 will be fine.
257.
So you should get 2 really nice numbers here. And what do you get as the coordinates of your vertex? What do you get as the coordinate of your vertex? 3.5, right? 196. Did you type it in right, Grace? So which one of those is the time that the rocket gets to the highest time? 3.5, and we're measuring it in seconds this time. So time is 3.5 seconds to get to the max, and the highest height is 196 feet.
Were we doing the maximum?
Yeah. So now we want to know, when does, what is it? Huh? No, what, maybe I did, I don't know. I thought it said 196. Now we want to find the time when the rocket reaches the ground. What feature of the graph is it when you reach the ground? The 0, so I want you to trace for me the X-intercept. Second trace, you're finding 0. Number 2, it also should be a really nice number. It is 7. Woo-hoo.
I know what it did.
So that means it took 7 seconds to reach the ground. So the rocket was shot up, 3.5 seconds in, it's at its maximum, takes 7 seconds to get down to the ground. Now the question that we're going to ask you about these is building off of what we did yesterday. What is the time interval that the rocket is falling towards the ground?
3.5 is less than X, which is less than 7.
Yes. So you can write it like that. You can also do interval notation. How would you write your interval? Brackets or parentheses? Parentheses. So if you did an interval here, you have to use parentheses. Now the last couple say what is the height after 1 second and 4 seconds. You can totally do second trace like we've been doing on the calculator. But if you get whole numbers like 1 and 4, you can also just as easily look at your table. All right, or you can do the second trace, find the value. But for whole numbers, it's really easy to look at your table here. At 1 second, you're 96 feet high, and at 4 seconds, you're at 190. That's you. 96 feet. All right, and then after 4 seconds, when you're over here somewhere, are you going up or coming down? You're falling down.
Hey, down.
All right, so it took us a little bit of time.